Greetings. My name is Robert Brentz. I'm a successful consultant, speaker, and trainer. I'm also the author of Shoot the Project Manager and the forthcoming Frank Sinatra Didn't Move Pianos. I created Rapid Skills Transfer for more effective instructor-led training and the 80-20 performance system that helps companies identify vital skills that produce outrageous success. I'm a member of the National Speakers Association and the American Society for Training and Development. I have almost 3 decades of experience developing and delivering programs for businesses, educational institutions, and associations in the United States, Canada, and Europe. My training is all rooted in practical experience, including work as an IT project manager. Some of the projects I've worked on have been a business process reengineering, online transaction process automation, a financial intranet for a major university, a customer service application for a financial services organization, a knowledge management subscription site, and a business-to-business portal site for a cellular telephone company. Some of my other clients have included America Online, the Bank of America, Bristol-Myers Squibb, Compaq, Hewlett-Packard, the Mayo Clinic, Merrill Lynch, Metropolitan Life, PeopleSoft, Pfizer, Qualcomm, Travelers Insurance, and the University of California. ITIL is a comprehensive and coherent collection of best practices for IT service management. ITIL is literally a library of these best practices, and as such, it evolves over time. It promotes a quality approach to achieving business effectiveness and efficiency in the use of information systems. Although ITIL describes and provides checklists, tasks, procedures, and responsibilities for many important IT functions, they can be tailored to any IT organization. ITIL focuses on service management because in the IT lifecycle, 70 to 80% of the overall time and cost is spent in the operations phase. More and more, IT service has to be reliable, consistent, high quality, and acceptable in terms of cost to the business. ITIL is intended to assist organizations to develop a framework for IT service management. Worldwide, ITIL is the most widely used best practice framework for IT service management. Driving the development of ITIL is the recognition that organizations are increasingly dependent upon IT to satisfy their corporate aims and meet their business needs. This growing dependency leads to growing needs for quality IT services, quality that is matched to business needs and user requirements as they emerge. In Chapter 1, I will present a broad perspective about ITIL. I will talk about what ITIL is and what it is not, who is using ITIL currently, what the benefits of using ITIL are from the perspective of the business, the customers and users, and the IT operation, what problems can and have occurred when organizations implement ITIL, what the 7 disciplines of ITIL are, and what IT service management is specifically and how it fits into the structure of ITIL. ITIL is a collection of best practices for IT service management. It is very flexible and can be tailored to any IT organization. The focus of ITIL is on the management of IT services. And the reason for this is because in the IT lifecycle, 70 to 80% of the time and cost is spent on the operations phase. This focus on the operations phase is a significant change from, say, even 10 years ago when IT was mainly focused on the application development part of the life cycle. ITIL is the most widely used framework for IT service management in the world. ITIL is very flexible and does not dictate what an organization should do, but rather offers a series of options and disciplines that can be implemented by each organization depending on what their specific needs are. It focuses on a collection of best practices from a variety of industries that can be used based on the needs of a specific organization. ITIL does not require a completely new way of thinking or acting. It basically provides a structured context for existing methods and activities and ways of improving those methods and activities to increase the quality of IT service management. Businesses have high expectations of quality of services. IT must concentrate on service quality and a customer-oriented approach, which is different than the previous focus of IT primarily on technology in past years. Service delivery is one of the ITIL disciplines that's concerned with setting up agreements with clients and customers and monitoring the targets that are agreed to. Service support is the mechanism that delivers the service as specified in the agreements between the business and the IT organization that's providing the business services. Who is using ITIL? Local, state, and federal governments in many countries are using ITIL, as are energy companies, public utilities, retail organizations, finance, and many other industries. Some specific examples include IBM, Hewlett-Packard, Microsoft, Shell Oil, Procter & Gamble, British Airways, and many other organizations too numerous to mention. What are the benefits of using ITIL? First of all, an overall benefit of using ITIL is usually reduced costs resulting from improved processes. Second of all, IT services are improved both in terms of the quality and the responsiveness to the business need. Third, improved customer satisfaction as the customer gains confidence that the IT organization will deliver the services that have been agreed to. Documented processes and procedures is another benefit of using ITIL because as the IT organization becomes more customer focused, they find that it is more beneficial to the organization to document all the processes and procedures which may have previously been ad hoc procedures or things that were known by one or two experts within the organization. Documenting the processes and procedures enables everyone to have access to the same information. Improved productivity is another benefit of using ITIL because the organization is focused on specific goals and objectives and focuses its energies on those goals and objectives rather than expending them in non-productive areas. And finally, improved use of staff skills and experience. As the organization implements ITIL techniques, the staff skills and experience grow based on the work that they do with the customer, and the sharing of this experience enables everyone on the staff to increase their skills. ITIL also has benefits to the customer and the user. The provision of IT services becomes more customer-focused, whereas previously IT services development and implementation were more technology-focused. The services are described in the customer's language rather than in the language of the technology being used to deliver those services. And the quality, availability, reliability, and the cost of services are managed better because IT service management becomes part of the operational structure of IT, and the focus is on these factors. Implementing ITIL also has benefits to the IT organization itself. Implementation of ITIL and ITIL processes, the IT organization achieves a clearer structure because it's focused on delivering the services to the customer. There's a more efficient and more focused on the corporate objectives rather than on the technology for its own sake. IT is also more in control of the infrastructure and the services because it's been given the responsibility and the mandate to provide an infrastructure that can ensure the successful delivery of the services that are requested by the organization. It's more service-oriented and more outward focused in order to meet the needs of the customer and deliver the services that are agreed to. And finally, ITIL can help improve communications between IT and the business customer by specifying a single point of contact between the two parts of the organization. As with any other new set of processes and procedures, the implementation of ITIL can result in problems. Some of those include the fact that introduction of ITIL, if it's attempted at the entire organizational level, can take a long time and be frustrating because it doesn't seem like results are being generated quickly. Sometimes implementing any new process, including ITIL, becomes an objective in itself, an end rather than a means, and people become focused on the processes of ITIL rather than the objective, which is the improvement of service delivery to the customer. Sometimes there's no improvement as a result of implementing ITIL because there's no understanding of what should be provided, what the appropriate performance indicators are, and how the processes can be controlled. Sometimes the improvement isn't apparent, and this is one of the biggest problems with implementing any new process, and ITIL is no different, because no baseline data was collected, or the wrong targets were identified, and so there's no way of measuring whether there actually was any improvement in the process. ITIL implementation can suffer because of a lack of commitment, and this includes lack of commitment all the way from top management through the individual staff personnel in the IT department that are implementing the ITIL processes. And finally, a lack of training and support tools can also hinder the implementation of ITIL. ITIL consists of 7 disciplines: service support, which I've mentioned briefly, and service delivery, which I've also mentioned, security management, ICT infrastructure management, and ICT stands for Information and Communications Technology, applications management, planning to implement service management, and the business perspective. ITSM, or IT Service Management, is a top-down, business-driven approach to IT service management. The focus in ITSM is the strategic business value that's generated by the IT organization. There are 2 main areas, or 2 main disciplines in ITSM: service delivery and service support. This diagram shows the 7 top-level ITIL disciplines that we've mentioned previously, and also the drill down in ITSM in terms of the practices within each of the 2 disciplines in ITSM, service support and service delivery, which we'll be talking in more detail about in just a moment. There are 11 practices in IT service management. This graphic shows the breakdown of those practices within the 2 disciplines of IT service management, service support and service delivery. Service delivery consists of service level management, where the agreements between the IT organization and the customer are reached and documented, capacity management, IT service continuity management, availability management, and financial management for IT services. Service support is how the customers and users actually get access to the services and how those services are supported by the IT organization. The practices consist of incident management, problem management, configuration management, change management, release management, and the service desk. This diagram shows the interrelationship and the flow of the ITIL 7 disciplines that we've mentioned briefly. What the business customers need, each one of the 7 ITIL disciplines is arranged in the order of the process flow that arrives eventually at the provision of the service to the customer by the IT service provider. The business perspective, and we'll talk about each one of these in turn as we go forward. The business perspective and planning to implement service management are the first stages of the customer's engagement with the IT service provider. IT service management, including service support and service delivery, are areas that we'll spend time in because this is really the core of IT service management. Infrastructure management and application management are 2 areas that are more the province of the IT service provider and help them in an organized and disciplined way create and deliver the service that the customer has requested. And over to the side you see security management, which is an area of great concern in the creation and delivery of IT services to the business customer. In Chapter 1, I've set the context for the detailed discussions of each of the 7 ITIL disciplines by talking about what ITIL is and what it is not, who is using ITIL, what the benefits of using ITIL are from the perspective of the business, the customers and users, and the IT operation itself, what kinds of problems can and have occurred when organizations implement ITIL, and a quick overview of what the 7 disciplines of ITIL are, and what IT service management is and how it fits into the structure of ITIL. The service delivery discipline consists of 5 practices: service level management, capacity management, availability management, IT service continuity management, and financial management for IT services. Service delivery is one of the two ITIL disciplines that make up what is referred to as IT service management, or ITSM. In this chapter, I'll talk about several aspects of each of the 5 service delivery practices, including their goals, the roles and responsibilities associated with those practices, procedures and action steps, and benefits and potential consequences of implementation. Service level management is the process of defining, negotiating, measuring, managing, and improving the quality of IT services at an acceptable cost to the business customer. Some of the key terms related to service level management are the customer and the user. The customer is typically the business client who's paying for the IT service, whereas the user or users are the group of individuals that are accessing the service that's provided under the terms negotiated with the customer. The service catalog is a description of the IT services that are provided to this specific customer under the terms of the service level agreement. The service level agreement is a formal document that is negotiated with the customer and the IT organization and signed off to indicate an agreement as to the level of service that's going to be provided by the IT organization to that specific business customer. Goals of service level management are, first, to reach an agreement with the customer about the type and quality of IT services that are to be delivered to that customer. Second, to make sure that those services are delivered with a consistent quality. Third, to actually implement the agreements that are reached with each individual customer for the provision of IT services. And in order to accomplish these goals, certain information is required. First of all, identification of the customer needs in very specific terms, especially in the customer's terms rather than technology terms. Second, information about the IT infrastructure and whether it can support the customer needs that have been identified. And finally, what the available financial resources are for supporting the development of the IT services that can support the customer's needs. There's one major role in service level management, and that is the role of the service level manager. Service level manager is responsible for maintaining the service catalog and also helping to develop and implement the service improvement program, which is a program of continuous process improvement in the delivery of services to the customer, overseeing the entire service level management process, beginning with the negotiation of the service level agreement, negotiating that service level agreement, and evaluating IT's performance against the criteria stipulated in the service level agreement to identify opportunities for service improvement. The procedures involved in implementing service level management include integrating service provision elements, putting together a series of elements that jointly combined can provide the quality and quantity of service required by the customer. Clearly document the services to be provided, again, in the customer's terms. So all services get described in the customer's terms in the service level agreement, or the SLA document. All of those services that are to be provided are clearly documented in the SLA. Fourth, to bring IT operations and business needs into alignment so that IT operations has a clear understanding of the needs of the business, the customers and the users, and business has a clear understanding of what IT operations can provide in the way of services and cannot, either because of limitations of financial limitations or limitations of the IT infrastructure, and to provide continuously improved IT service delivery. Service level management has a number of action steps, and those include identifying the needs of the client or customer, defining the services to be delivered, negotiating the contract, monitoring that contract, reporting on the statistics related to the performance of the contract, and going through a process of review and improvement, which may in turn return us back to the state of modifying the contract. Identify action step. Since the customer is often unclear about their expectations, the identification process is a matter of discovery sometimes about exactly what the customer requires in specific terms about related to the service that's going to be delivered to them. Customer needs must be quantifiable since they're going to be measured against benchmark or service implementation. Customer needs need to be quantified, which also facilitates an understanding of the perception of service quality, which can be both quantifiable in terms of what service was actually delivered, but also a quantitative aspect in which the customer is surveyed on a regular basis to gain an understanding from the IT operation of the customer's perception of the quality of service that's being delivered to them. Some of the kinds of ways of perceiving service quality can be related to the cost-benefit analysis. Is the benefit the customer receiving greater than the cost of the service that's being provided that the customer is paying for? In the define action step, the things that get defined as we go through this part of the process are the scope of the service to be delivered, standards. What level of standard does the customer expect, for example, in terms of being able to access the application that's providing the service? Some customers will have a higher standard of requirement depending on their mission-critical nature of the service that's being provided to them. Other customers can work with a lesser standard in terms of availability, and sometimes this is also determined based on the customer's hours. If the customer doesn't need 24-hour-a-day, 7-day-a-week access to their application, then they can sometimes work with a lower standard of availability simply because there's no one using the application during certain hours. Once the customer's standards have been determined, the next step in this process of definition is to convert these metrics into the service provider's standards and create a plan for the service delivery and the quality of service that's going to be delivered. The next step, contract, involves the process of negotiating the service level agreement. The service level agreement has to take into account the environmental conditions, meaning the conditions of the whole business, which include the size, complexity, geographical distribution, and other factors of the customer's organization, the languages, the current organizational structure, the cultures, and so forth, if a company is multinational and is spread across many countries throughout the world, and the type of business activities the customer is contracting for, and the hours of operation. These and many other factors go into the negotiation of the service level agreement. The process of monitoring, the action step of monitoring the implementation of the agreement, has to be performed in such a way as to satisfy the customer's perspective of the kinds of activities that are being undertaken to measure the quality and quantity of service that's being delivered to the customer and the customer's users, and technical metrics that are captured by IT in order to measure, again, the performance of the IT infrastructure in terms of meeting the customer's requirements, and also procedural aspects. Were the proper procedures being followed during the time period that's being measured, both by the customers and the users, as well as the IT organization? Service benchmarks are typically established for monitoring purposes, for example, response time from the service desk or availability time and so forth. In the reporting action step, metrics such as availability of the application or the service to the customer versus the amount of downtime that was experienced in a certain service period. Average response time, how long it took for the service desk to react to a problem that was reported, how long it took to get that application back into service or identify a workaround for the customers and the users to get back to work. How many transactions actually took place using this particular service application? How many service outages, different than downtime, service outages related to uncontrollable factors such as power outages and network outages and so forth. Security. Security will be a whole separate topic that we'll talk more about in detail, but security involves things like how many attempted unauthorized accesses to the system were recorded and so forth. How many changes or change requests were submitted by the user or by the IT organization based on the kinds of modifications to the application or the service that's being provided that were identified by either the customer or the users or the IT organization for improving the quality and the availability and so forth of the service. And finally, and in some people's viewpoint, most importantly, what were the costs related to the provision of the service during the period that was being measured? The final step is review and improve, in which we take the existing service level agreement, we take a log of all of the problems that were reported by the users and the customer, and we establish what the trends are related to those problems. And was there a certain area of problems that kept cropping up repeatedly? Or was there a trend in terms of how many new kinds of problems cropped up? Or did the number of problems from the previous period decrease during this period? Did new problems crop up, and so forth? Were change requests submitted by the users or by IT? How many of those changes were requested? How many of them were determined to be required changes, things that needed to be done, and changes that needed to be made in the environment? And the consequences of the trends, the problems that were identified, and the changes that were requested in terms of what consequences and what the implications are for the existing service level agreement and how that document might need to be changed. There are a number of service level benefits that accrue from implementing service level management. First of all, the relations with the customer and customer satisfaction improves. IT can manage its costs better because it knows specifically what services are required by the customer because they're specified within the service level agreement or the SLA. IT services get created in response to, with the expectation that they will meet the customer's expectations. So the rule of thumb with a service level agreement is, if it's not in the service level agreement, IT doesn't create and deliver a service. IT services now get measured, reported, and managed within the service level agreement because of the specifications in that document. The strategy becomes better aligned with the business needs because of the communication between the IT organization and the customers of the business that are providing these specifications for the kinds of services that they need in order to perform their activities. And there's greater clarity of communication between the IT organization and the customer as the customer gains confidence in IT's ability to deliver the services, and IT requests and requires information from the customer in order to be able to develop and deliver the kinds of services that will benefit the business customer. There are potential consequences of implementing service level management that organizations and businesses and the IT organization both should be aware of before proceeding. First of all, sometimes there is a tendency to attempt to do too much all at the same time. And this can lead to frustration because a lot of work goes in the front end and it doesn't appear that anything's being accomplished. So a potential consequence, mitigation of that consequence, can be to very carefully scope the implementation of service level management. Sometimes there are difficulties in creating metrics for measuring the quality and the quantity of services delivered by IT to the business customer. And sometimes there's a difficulty in reaching an agreement about them. The business customer has one set of objectives that they want measured in a particular way, and IT has a way of measuring service delivery metrics that may be more quantitative than qualitative. Sometimes there is a conflict in the organization's culture between the IT organization and the customer's portion of the organization. IT tends to be very technology-centric, and the customer, of course, is very business-centric. And sometimes there's a discussion or a dialogue needs to take place between these two areas to have an understanding and appreciation of each other's perspectives on the approach to the service that's going to be delivered by the IT organization. Another potential consequence is the process can be difficult to manage because the initial requirements were unclear. The negotiation process in creating the SLA is very critical, and because it becomes the foundation for all future discussions between IT and the customer, and it becomes the basis by which the service itself is created and delivered and also measured and managed. Sometimes the service level management documents and procedures become ends rather than means. People get caught up in making sure that all the documentation is done and all the procedural checklists are followed and so forth, rather than understanding that they're a means to an end, and that is the creation and delivery of the quality and quantity of services requested or required by the business. And finally, sometimes the final document just turn out to be unrealistic, because either the customer has expectations of IT that IT cannot fulfill because of infrastructure restraints or budgetary restraints and so forth, or IT misunderstands the kind of services that the business is requiring or needing for its operations, and in essence delivers the wrong product or the wrong service. Capacity management is the second of the ITSM practices. The objective of capacity management is to provide cost-effective data processing and storage capacity as needed by the customer, as specified in the service level agreement. There are two key terms related to capacity management. Performance optimization, which means the ability to measure, monitor, and tune the IT infrastructure in order to provide those data processing and storage capacity requirements, and capacity planning and modeling, which is the proactive part of capacity management, in which we run simulations, perform trend analysis, and do modeling in order to plan for future capacity needs based on the requirements of the business customer. The goals of capacity management are simple: to provide the required IT resources to the customers at the right time and cost based on the current and anticipated business needs. Capacity management has one major role: the capacity manager. The capacity manager's responsibilities are, first, to manage the capacity management procedures, the written documentation about how to execute capacity management responsibilities. Second, to develop and maintain a capacity plan, which is that document that sets forth the existing capacity of the IT organization, as well as any plans or proposals for acquisition or tuning of existing capacity or acquisition of future capacity, and to keep the capacity database current so that the other ITSM procedures can make use of the information there when, for example, an incident is reported having to do with a lack of capacity to run a business application. Three levels of procedures in capacity management. First, business capacity management, which is related to performing trend analysis, making forecasts, doing modeling, prototyping, assessing size requirements, and documenting all of these results in terms of projecting forward the amount of capacity that can be made available with the existing infrastructure and what new components of the infrastructure may need to be added to meet the requirements of the business. The second procedural area is service capacity management, which is executed at the service level and involves monitoring, analyzing, tuning, and reporting on performance of the existing infrastructure as it's currently implemented to deliver this business services, and to establish baselines for service usage, which will contribute to the SLA review when we actually measure the quality and quantity of services delivered to the business customer, and finally, to manage service demand so that activities such as balancing can take place. If several applications are using a lot of resources at a particular time of day and causing capacity problems, it may be possible to move the execution of one of those applications to some other time when there's more capacity available for that particular application to run. Finally, at the component level, resource capacity management looks at the performance of and the capacity of each individual component that works together in the IT environment to provide the service to the customer. Capacity management consists of 9 steps, and we're going to look at each one of those in turn. The first step is to develop the capacity plan. Capacity plan delineates the current and projected future IT infrastructure capacity requirements based on customer demand, projects changes in IT services demand either of existing services or projected future services, and results from revisions to existing service level agreements and new service level agreements that may be concluded with the client. The cost projections also get built into the capacity plan so that the business has an idea of the anticipated costs of increasing the capacity of the IT operational environment. Finally, the capacity plan is reviewed on a quarterly basis, typically along with the review of the existing service level agreements. The second action step is to model. Modeling is used to forecast infrastructure responses to future customer demands for services. Some of the techniques involved in modeling are trend analysis, and I won't go into the details of linear versus nonlinear, but there are several different kinds of trend analysis that take existing data and attempt to project it into the future to forecast infrastructure requirements. Simulation can be done with software, for example, that takes the existing information and creates a simulation of a future scenario based on the existing information about capacity and demand for capacity. Benchmarking and data collection is another technique for forecasting infrastructure requirements and tends to be the most reliable because it uses information from other parts of the business or other businesses that have already dealt with the kinds of forecasting requirements that this particular action step is undertaking. The trade-off in the modeling process is how long it takes to do the modeling versus the amount of resources required versus the reliability of the kinds of forecasting that can be done. Typically, the more expensive and the longer it takes to do some kind of a forecast, the more reliable or the more accurate it will be. The third action step is sizing the application. Sizing the application attempts to determine the amount of resources required for new or revised service and attempts to project the expected performance of the environment and the necessary resources to meet those expectations. Estimating the cost of acquisition so that a reliable budget can be created for acquisition of new equipment if necessary, for example. And one outcome of the size application action step is to estimate the impact of a workload variation. For example, what if the number of users using a particular application or business service increases by 20%? The next action step is monitoring. Monitoring tries to make sure that the service levels that are provided match those that are stated in the service level agreement. This includes a number of resources in the environment, such as central processing unit throughput, the average percent of memory usage over time, the network bandwidth consumed, and so forth. After this step, the next action step in the process is to analyze. Basically, we're analyzing the data that was collected during monitoring. We do our trend analysis, attempting to foresee future constraints on service provision and anticipate those and make provision for addressing those problems. And the results of the analysis tend to be the optimization of the existing infrastructure to the maximum extent possible, and or the purchase of new components if we've reached the limit of optimization of the existing infrastructure. The next action step is tuning. Tuning uses the analysis of the monitoring data to optimize infrastructure components for either the existing measured or anticipated future workload. The next action step, implement, has the goal of successfully adding the changed or incremented infrastructure components without resulting in a disruption of service to the existing users or customers. If a change is involved in the infrastructure, both change and release management will get involved in handling the actual implementation of the change. We'll talk about those two practices later on. The next action step is to manage demand. Sometimes it's not necessary to add new infrastructure components, but rather to manage the demand in such a way as to make the best possible use of the existing capacity. And one of the parts of that action step are to adjust the capacity demand. And an example of that, as I mentioned earlier, would be to run a batch job during non-peak demand time frames versus during the busiest workload. Data from this particular action step of this practice can provide input into the SLA review so that both the business and the IT operational representatives can assess whether the capacity needs to be increased in terms of the amount of number of components within the IT infrastructure, or whether there are areas of sand where the capacity can be shifted and make the best use possible of the existing infrastructure. The data from this practice can also be used to create a split charge pricing structure. Just as With some utility companies, there's an on-peak and an off-peak pricing structure, depending on when you use your natural gas or electricity. Organizations that have a chargeback process for charging the business customer for use of the capacity of the IT infrastructure sometimes implement a split charge pricing structure where there's a higher charge for on-peak than off-peak usage of the infrastructure. The final step is the creation and the maintenance of the capacity database. Inputs to the capacity database include information from business forecasts and financial, service, and technical data that's collected as part of the capacity management optimization process. This creates and maintains a capacity database that at any given time tells what kind of capacity is available to the business users. Some of the outputs of the capacity database are management and technical reports that report out in statistical terms for management consumption and consumption of the IT operation and the customers what exactly the capacity of the infrastructure is and how well it's being utilized, and plans for optimization or increases to the capacity of the IT infrastructure. Some of the benefits of capacity management are a reduced risk to existing services by effectively managing available resources. In other words, we talked a moment ago about on-peak versus off-peak charging and encouraging the customer to make use of the existing available capacity. And by effectively changing the balance of the capacity, the demands on capacity, we can reduce the risk to the existing services and the risk of having those services not be available because the system reaches and exceeds its capacity, making the applications slower to execute, for example. There's a reduced risk in implementing new services because with a capacity database, we know what the capacity is, we know what the infrastructure looks like, so when we implement new services, we can assess whether the capacity exists to support that new service or whether further optimization needs to be done or new capacity needs to be added to the system. Costs are reduced because by attempting to optimize the capacity of the system before purchasing new components for the system, we can reduce the costs associated with buying new components because we make the best use possible of the existing IT infrastructure. We can reduce service interruptions, again, by monitoring capacity on a regular basis and making plans for optimizing or increasing the amount of capacity in the IT infrastructure. There's a better balance of resource supply and demand. Again, encouraging those lower priority or off-peak kinds of activities being run when more capacity is available gives us a better balance of the use of the resources to meet the demands of the business customer. There's also a better use of available capacity because there's less idle capacity. We don't have peaks and valleys. There's fewer peaks and valleys in terms of capacity because we're attempting to optimize and balance the capacity of the system. Some of the potential consequences of capacity management are unrealistic expectations. Sometimes the business customer feels that with adequate capacity management, there would never be any need to add new capacity to the IT infrastructure, for example. Sometimes there is a lack of reliable information about the workload or about the service demand because, again, the data collection tools haven't been set up properly to collect the information needed for satisfactory capacity management. In complex IT environments, capacity management can pose some implementation problems because there may be multiple servers in multiple locations running redundant services or having failover capabilities that make it difficult to assess the actual capacity of the system that could be made available to providing the business service. There's also the possibility of either too much or too little monitoring. Too much is not a good thing because it costs money to do the capacity monitoring. Too little, of course, may result in capacity outages, system outages, because the capacity wasn't optimized appropriately. And finally, implementation of any new system, including capacity management, can suffer from a lack of support from top management because sometimes they don't see the immediate benefits of implementing a practice like capacity management. Availability management is a critical practice in IT service management because downtime or unavailability of the IT infrastructure means financial consequences to the business. There are 4 key terms related to availability management. First, available means the IT services are continuously available to the customer per the requirements in the service level agreement. As I discussed a little bit earlier, some customers need 24/7 availability of their applications, and other customers do not because of the nature of the service that's being provided and consumed by the users. Reliable means that the service is available as agreed, that there aren't any variances or unevenness in the quality of the service that's available. Now, reliability has to do with being sure that when the user logs in, the service is available. Maintainable means that the service can be kept operational and be restored quickly, in parentheses, if there is a failure in the service. Maintenance is a key part of meeting the requirements of the customer, and they're frequently specified in the service level agreement. Serviceable means when dealing with external service providers, the contracts with those external service providers specify the kind of service that is to be provided by them and on what kind of a time schedule and what the expectations are for restoring service if there's a service outage or a failure of the service. The goals of availability management are, first, to provide cost-effective, predefined availability of IT services as prescribed in the service level agreement. Successful availability management leads to higher customer satisfaction, so it's important both to IT operations as well as the customer to clearly define the availability of the services in the SLA. Another goal of availability management is the timely response to service outages, so that any outages are responded to quickly and services restored also as quickly as possible to minimize the downtime for the users. And the design of procedures based on an understanding of both IT and business to be able to meet these goals of availability management. The main role in availability management is the availability manager. The responsibilities of the availability manager include defining and developing availability procedures so that there is a set of documentation related to the availability of the IT infrastructure. Monitoring and making sure that available service levels match the service levels agreed to in the SLA. Collecting data about availability and generating reports both to the customer and to senior management. And making the best possible use of IT infrastructure in order to deliver the highest availability services possible to the business customer. Procedures related to availability management include both inputs and outputs. In terms of inputs, availability management procedures include the customer's availability requirements, the incident and problem data that exists about availability of the IT infrastructure, and any configuration data that may be available to help assess the availability of the IT infrastructure for providing services to the business customer. The outputs are a generation of availability and recovery requirements, the ability of IT to deliver availability and recover from service outages and failures, the risk tolerance, in other words, the ability of the system, how risky certain kinds of implementations of services might be to the availability of the IT infrastructure, and monitoring, which is the process of collecting and reporting data related to the availability and any recovery from service outages and other problems that may have occurred in the IT infrastructure environment in the context of delivering services to the customer. Availability management has a number of action steps. They fall into 2 groups. Plan, which includes availability requirements, design, and the availability plan itself. Maintenance of availability, planning for recoverability, and planning for security. The monitoring phase, or the monitoring action step in availability management, includes measurement and reporting. action step is to determine availability requirements. This involves identifying key business services and hours as required by the customer, specifying IT service downtime definitions, and creating availability metrics for determining the actual availability that was provided by the IT infrastructure. Identifying the impacts of unanticipated downtime is another aspect of determining availability requirements, as opposed to planned downtime. Planned downtime being time reserved for implementing changes, doing maintenance, and that sort of thing. Unanticipated downtime would be caused by foreseeable factors such as power outages or network unavailability and so forth. It's important during this action step that the customer and the IT operations organization come to an agreement about when maintenance is going to be performed. As many applications move to a 24/7 availability requirement environment, it becomes more and more difficult to identify times when maintenance can be performed. And it becomes a matter sometimes of finding the least inconvenient time of performing maintenance. Many application providers specify and notify their users in advance of a planned maintenance window so that those users can plan to be not using the application during that period of time. The next action step is availability design, which involves identifying the vulnerabilities of the system which may impact availability, determining the customer's standards of availability, then identifying the best option available to meet the customer's expectations, and improving the design continuously to improve the ability of the system to recover. Maintenance design, the next action step, basically attempts to refine the information about the availability of the system that's required by the customer. The terms in the industry, 3 nines versus 5 nines, have to do with the amount of availability in terms of a percentage. 3 nines means that the system is available 99.999, or 3 nines, % of the time. 5 nines, a much higher level of availability, means the system is available 99.99999% of the time. 5 nines turns out to be approximately 40 minutes of unavailability per year, which is a very high standard to meet. Many organizations, many business customers do not require 5 nines or sometimes even 3 nines, and they should be made aware of the implications of striving for this level of availability in terms of cost. Maintenance design relies upon an effective incident management system in order to promote recoverability. Incident management is another ITSM practice we'll cover a little bit later on, which has to do with the initial reporting of incidents, service outages for example, by the users to the service desk, which lead to a whole host of activities to attempt to restore service to that customer. Some of the pieces of incident management that affect the maintenance design have to do with how an incident gets escalated and how quickly, how information is communicated and to whom, and how information is reported back to the business user and the business customer. And finally, the maintenance design also includes procedures related to backup equipment and recovery procedures for restoring service to the customer. Again, these backup equipment, recovery procedures, failover servers, many of these kinds of things related to IT infrastructure have a cost associated with them, and therefore the customer has to make a determination as to what level of availability they need and what kind of recovery and backup they're willing to pay for. Security issues, again, in terms of availability, although we'll cover security in more depth a little bit later on, security issues related to availability have to do with what kinds of areas of the IT infrastructure need to be secured, who is authorized to access those secure areas, for example, payroll information, personal information about employees, who has access to that kind of secure information, who can issue authorizations for access to those various secure areas. Managing maintenance as an action step comes back to the process of defining, agreeing to, and implementing maintenance and change activities. In other words, what's the definition of a maintenance or a change activity so that the customer has a clear understanding. Some of the benefits of availability management are there's a single point of contact. Availability management has a number of action steps. They fall into two groups. Plan, which includes availability requirements, design, and the availability plan itself. Maintenance of availability, planning for recoverability, and planning for security. The monitoring phase, or the monitoring action step in availability management, includes measurement and reporting. The step is to determine availability requirements. This involves identifying key business services and hours as required by the customer, specifying IT service downtime definitions, and creating availability metrics for determining the actual availability that was provided by the IT infrastructure. Identifying the impacts of unanticipated downtime is another aspect of determining availability requirements as opposed to planned downtime. Planned downtime being time reserved for implementing changes, doing maintenance, and that sort of thing. Unanticipated downtime would be caused by foreseeable factors such as power outages or network unavailability and so forth. It's important during this action step that the customer and the IT operations organization come to an agreement about when maintenance is going to be performed. As many applications move to a 24/7 availability requirement environment, it becomes more and more difficult to identify times when maintenance can be performed. And it becomes a matter sometimes of finding the least inconvenient time of performing maintenance. Many application providers specify and notify their users in advance of a planned maintenance window so that those users can plan to be not using the application during that period of time. The next action step is availability design, which involves identifying the vulnerabilities of the system which may impact availability, determining the customer's standards of availability, then identifying the best option available to meet the customer's expectations, and improving the design continuously to improve the ability of the system to recover. Maintenance design, the next action step, basically attempts to refine the information about the availability of the system that's required by the customer. The terms in the industry, 3 nines versus 5 nines, have to do with the amount of availability in terms of a percentage. 3 nines means that the system is available 99.999, or 3 nines, % of the time. 5 nines, a much higher level of availability, means the system is available 99.99999% of the time. 5 nines turns out to be approximately 40 minutes of unavailability per year, which is a very high standard to meet. Many organizations, many business customers do not require 5 nines or sometimes even 3 nines, and they should be made aware of the implications of striving for this level of availability in terms of cost. Design relies upon an effective incident management system in order to promote recoverability. Incident management is another ITSM practice we'll cover a little bit later on, which has to do with the initial reporting of incidents, service outages for example, by the users to the service desk, which lead to a whole host of activities to attempt to restore service to that customer. Some of the pieces of incident management that affect the maintenance design have to do with how an incident gets escalated and how quickly, how information is communicated and to whom, and how information is reported back to the business user and the business customer. And finally, the maintenance design also includes procedures related to backup equipment and recovery procedures for restoring service to the customer. Again, these backup equipment, recovery procedures, failover servers, many of these kinds of things related to IT infrastructure have a cost associated with them, and therefore the customer has to make a determination as to what level of availability they need and what kind of recovery and backup they're willing to pay for. Security issues, again, in terms of availability, although we'll cover security in more depth a little bit later on, security issues related to availability have to do with what kinds of areas of the IT infrastructure need to be secured, who is authorized to access those secure areas. For example, payroll information, personal information about employees. Who has access to that kind of secure information? Who can issue authorizations for access to those various secure areas? Managing maintenance as an action step comes back to the process of defining, agreeing to, and implementing maintenance and change activities. In other words, what's the definition of a maintenance or a change activity, so that the customer has a clear understanding when we say maintenance or change, that they understand what we're talking about. Agreeing to is part of the SLA process and attempts to achieve a consensus or agreement between the customer and the IT organization about things like when maintenance is going to be performed, how it's going to be implemented in terms of the unavailability of the service, and so forth. Information from this action step gets communicated to the change management process, because change management is responsible for the rollout of any changes to the IT infrastructure. Measuring and reporting, again, involves the collection of information based on certain key metrics. For example, mean time to repair, how long it takes to repair a problem, hardware or fix a software problem. Mean time between failures, a very important metric in measuring and reporting related to availability, because mean time between failures has to do with how long we can expect, say, a hardware component to work before we can expect the quality of its operation to degrade or the component to fail. A hard drive, for example. There's a mean time between service incidents that's also calculated in the same way. Based on the statistics that we collect about incidents that get reported to the service desk, we can calculate approximately how long a time period may elapse between service incidents, between the time that certain kinds of problems are reported to the service desk. The next action step in this process is to develop the availability plan, which is a collection of all of the information that's been the product of the action steps previous to this. The availability plan is a long-term document. It's intended to be reviewed and revised on a regular basis, typically quarterly, and typically in sync with revisitation of the capacity plan and the service level agreement. Availability plan is different than the capacity plan in that they deal both with the IT infrastructure, but one has to do with the physical infrastructure that provides capacity versus the availability of applications based on any changes to the environment that impact the availability of services to the business. The availability plan describes the current availability situation and provides both quantitative and qualitative information related to that. It sets forth planned improvements for existing services, as well as plans for new services that may be negotiated as part of new service level agreements. It also delineates the maintenance guidelines that I discussed previously in the maintenance action step. Some of the benefits of availability management are there's a single point of contact between the business customers and the IT infrastructure availability management area. New services can be developed based on customer needs, and the availability of the infrastructure to support those new services can be quickly identified and managed proactively. Availability management increases the acceptability of costs, or improves the acceptability of costs to the customer by assessing the availability of resources and being able to accurately forecast whether the current infrastructure is satisfactory to provide availability for new services, or whether new infrastructure needs to be added in order to provide those the availability for the new services. There's a continuous monitoring and improvement process in place related to availability of the infrastructure to support those business services required by the customer. Corrective actions are taken in a timely and appropriate manner, on a timely basis, and in an appropriate manner, because there's not only this practice, this availability management practice in place, but this practice communicates with the other practices in ITSM in a symbiotic way to provide maximum response time or minimum response time in terms of taking corrective actions to ameliorate problems in the environment. There is a paradigm shift that takes place when availability management is implemented properly. And that shift is a focus, a proactive focus on improving service versus a continual reactive management of availability in terms of fighting fires when problems crop up, which they seemingly continually do when you're in that mode. Some of the potential consequences related to availability management are, first, responsibility for availability management is not centralized, and there's no support for doing so. In large, complex IT infrastructures, there may be more than one availability manager, and there's no coordination between them. Sometimes, the IT organization considers the current availability adequate to deliver the services to the customer and doesn't feel that it's necessary to implement availability management. The availability manager does not have sufficient authority to make proposals or changes in order to make adjustments in the availability based on tuning and tweaking the IT infrastructure environment. Sometimes the resources for the availability that's desired by the customer is underestimated, and availability problems crop up on a regular basis because there's an insufficient amount of IT infrastructure to support the level of availability that's been required by the business services that are being provided to the customer. If there's inadequate or ineffective monitoring and reporting, availability management will not be successful because there's not enough information to be able to make adjustments to the environment to provide the level of availability required by the customer and by the users. And finally, availability management does not operate in a vacuum. If there are no supporting processes which provide information to and resolve problems associated with availability management, such as problem management, availability management's implementation will not be successful. The next area of service delivery is IT service continuity management. IT service continuity management has to do with disaster planning and planning for recoveries from disasters. And in this context, disaster is defined as any event that disrupts service or the system and requires a major effort to restore it to its original performance level. This is a more catastrophic kind of event than a simple service outage. And disasters are more common than people would think, because normally we think of serious kinds of natural disasters and so forth, and they can be. Fire, lightning strikes, but they can be things like sabotage, power outages, hardware failures, denial of service attacks, and a wide variety of things that can disrupt the service to the client. IT service continuity management has only one goal, and that is the restoration of critical IT infrastructure and business services within a specified time after a disaster. There are a number of roles related to ITSCM, the main one being the IT Service Continuity Manager. But in addition to this particular role, there are many others that have a role to play in the development of a service continuity management plan. The corporation's board or organization's board of directors can influence policy. Senior management can give direction to both the IT Service Continuity Manager and, in a larger scope, the business continuity planning process. Mid-level managers all have input into prioritizing the services that need to be restored in the event of a disaster, and project leaders and team members also have a responsibility to help identify the kinds of services that would be most severely impacted by a disaster and what the actual nuts and bolts process of restoring the service would be. There are 7 key procedures in IT service continuity management. The first one is risk assessment. In other words, determining what the risk of any given disaster, natural or otherwise, is. Assess the impact of that disruption. In other words, a lightning strike may have a different impact on the organization than sabotage or a denial of service attack. Identify what the critical services are and the order in which they would need to be restored to keep the business or to get the business back in business as quickly and efficiently as possible, to define the required service restoration timeframes to determine how soon which services need to be restored, to mitigate the risks and prepare contingencies. In other words, mitigate risks means reduce the impact of those risks, and prepare contingencies means what would we do if a meteor hit the IT operations center? How would we recover from that disaster? Define the steps. In other words, establish a checklist of steps that we would need to go through in order to restore the services in the order that they were prioritized during an earlier step, to create and maintain a recovery plan so that in the event of one of these kinds of natural or other kinds of disasters, that there would be documentation available that could be followed by the organization to restore the services, again, in the order, in the priority order of how critical they are to the business in an orderly manner. The action steps in IT service continuity management are, first, to define the scope of ITSCM. What is the range of coverage of service continuity management for IT? Analyze the impact on business of a potential disaster. To assess the risk, a formal step in risk assessment. To develop a strategy for service recovery of the IT operations so they can begin delivering business services again. To plan the implementation, what specific steps would need to be taken in order to implement the strategy. Identify and document preventive measures that can be taken before a disaster strikes the organization, and create the recovery plans and procedures that we talked about a few moments ago. The first action step is to define the scope of IT service continuity management. This involves defining the policy and communicating that policy to the business customer, other stakeholders, senior management, the board of directors, and the IT organization. This requires a management commitment. This is the first point at which you really have a test of how committed the organization is to service continuity management, and that is by getting a management sign-off on the policy document prior to communication. The next piece of this action step is to define the scope of the service continuity plan for IT. What are the organizational structures? Who has what responsibilities? What processes are going to be recovered in what order, and so forth? All must be identified in order to define the scope. The next step is to allocate resources for training of people who would be involved in service recovery, and also the facilities. Sometimes, in the most extreme cases, service continuity management involves constructing a duplicate facility that matches your IT operation and duplicating the infrastructure in a separate location in case of a natural disaster occurring in a particular location. After those resources have been allocated, the scope has been defined, policy has been defined and communicated, and so forth, the next part of this process of defining the scope is actually to set up the recovery structure in terms of who's responsible for doing what, and when, and in what order, and so forth. The next action step is to analyze the impact of service continuity management on the business. The first point to address, of course, is the restoration of services in the case of a disruption. The next is the prevention of disruption of the most mission-critical services. Is there some way that we can set up an IT infrastructure so that in case of a disaster, the most mission-critical services are not disrupted at all? Then IT service needs to be prioritized in accordance with the service level agreements. And this is, again, goes back to part of the negotiation process with the service level agreements with the different customers who we're going to provide business services to. Part of this action step is to assess the dependencies that exist within the IT infrastructure. What are the capacity and availability impacts of a disaster that doesn't completely wipe out the IT operation? What are the recovery options in the case of different kinds of disasters that might occur to the IT operation? Assessment involves identifying first the type of exposure. What kinds of things are more likely to happen to your IT infrastructure, your IT computing center, for example, than others. For example, certain parts of the country are more susceptible to earthquakes, others are more susceptible to tornadoes, and yet others are more susceptible to floods and those kinds of natural disasters. There are a number of steps in risk analysis. To summarize them here, first, identification of IT assets. What are the assets of the IT infrastructure that would need to be replicated or replaced or put back into service in the case of a natural disaster? Configuration management, another one of the ITSM practices that we'll talk about later, maintains a configuration management database that contains all the information about all of the IT assets, and this would be the source of information for this step in risk analysis. The next step is to analyze the threats and the probabilities of disasters. Once we've identified what they are, what kind of a threat does a flood, for example, pose to our IT operations? And what is the probability of that kind of a disaster happening to our IT operations center? Identify the vulnerabilities. In addition to the kinds of threats that the infrastructure may be exposed to, what kinds of vulnerabilities in terms of the business does this kind of a disaster pose for us in maintaining the service level or restoring the service level to the business operation? Estimating risk levels is the next step in risk analysis, and that basically is either a statistical or a qualitative or a combination of both analysis of what is the likelihood of, say, a magnitude 6 earthquake striking our IT operations center, or a level 5 hurricane striking our IT operations center facility, and so forth. And estimating how risky that is, how risky one of those kinds of disasters is, in terms of how often is it likely to happen, and how severe is the risk in terms of, for every 10 level 1 hurricanes, we have 3 level 5 that would really seriously threaten the survival of the IT operations center. IT service continuity strategy is a product of many of these steps that we've looked at before, and involve developing prevention measures based on the risk analysis versus the cost. It would be ideal to have a duplicate IT center somewhere else in the country that we could turn on, in effect, if our main center was destroyed by a meteor strike, for example. But many companies elect not to spend the money on that kind of infrastructure because the larger and more complex the infrastructure is, the more expensive it is to duplicate. And so other prevention measures are looked into rather than simply setting up a complete duplicate center. What are the different recovery options that are available to us as we develop our continuity strategy? For example, we can take no action. We can say, well, it's not going to happen to us, kind of the head in the sand approach. This isn't going to happen to us. We're not going to worry about it. The disasters are so unlikely to happen that it's not worth having a service continuity plan. The next approach is, well, we can always go back to a manual system, which is just about as unrealistic as taking no action, because manual systems would be hard to bring back up, and the purpose of the computer systems is to make our business run more smoothly and more quickly. Reciprocity is an option that many companies look into because if they have business trading partners with a similar infrastructure in different locations, sometimes a reciprocity agreement is reached with those trading partners to duplicate parts of our infrastructure in their environment, and we duplicate parts of their infrastructure in our environment. The next piece of the recovery options is which pieces of the business service environment have to be recovered slowly at an intermediate speed or quickly. For example, within 72 hours or between 24 and 72 hours or within 24 hours of the disaster. And again, this is a decision that has to be made on a case-by-case basis and based on each business's requirements and needs. The next action step is actually to perform the implementation planning, how the organization will respond to an emergency. This involves how the organization is going to assess the severity of the disaster, how the organization is going to implement the recovery steps, and where the critical records will be stored safely in the case of a disaster so they can be restored to the restored IT infrastructure environment. Have to be made about who's in charge of managing the crisis. Typically, there's one person on the IT side and one person on the business side who coordinate efforts, because the IT Service Continuity Management Plan typically works hand in glove with the organization's Business Continuity Management Plan. Sometimes it's called the Business Recovery Plan. Again, implementation planning also has to do with how is the off-site recovery facility, if there is one, how is it going to be, in effect, turned on and brought into service. And during implementation planning, considerations also have to be made for how is that off-site recovery facility going to be kept up to date so that if we need to use that recovery facility, it is an exact mirror image of the existing infrastructure that was lost as a result of the disaster. The next action step is to take preventive measures. If there are things that can be done to prevent a disaster from disabling the IT operations and bringing down the business services, things as simple as backup power supplies, some fault-tolerant systems, sometimes in the case of a server failure, a server disaster, some kinds of fault-tolerant systems, failover server farms, and that kind of thing at different locations can mitigate the impact of a disaster. Off-site data storage, we mentioned a little bit earlier. Off-site data storage can be some kind of a hardened location that the data can be stored in that is relatively more impervious to the impacts of a disaster. Something as simple as a disaster affecting disk drives, using RAID levels for the appropriate amount of redundancy to assist in the restoration of information as quickly as possible. All of this culminates in the recovery plans and procedures. Recovery plans and procedures for ITSCM include all the aspects that are relevant to restoring the business and IT operations. It involves structuring a plan so that the pieces can be created and modified as necessary. Typical plan structure includes an introduction, a delineation of the updates that have been made to the plan over time, routing, who sees the plan and who's responsible for approving or signing off on the plan, how the plan gets initiated, under what circumstances would the disaster plan be initiated, what kinds of contingencies have been identified and how are they classified in terms of severity or likelihood and so forth, and then sections having to do with each specialist area of the recovery process, such as hardware, software, third-party client, third-party customers, third-party suppliers, locations, and other kinds of geographical locations, and other very specialized sections of the plan that will tell the people who are responsible for doing those pieces what their responsibilities are and how they should accomplish the objectives of that section. The procedures overall for the plan itself would be things like installing, testing the hardware and the network components, restoring applications, restoring databases, getting the hardware and getting the software applications running on the hardware and able to deliver the business services. And finally, during the recovery plans and procedures action step, would be testing all of this to make sure that it actually works before a disaster actually occurs. The benefits of IT service continuity management are IT is able to successfully recover mission-critical services and systems and restore business services. There is a mitigation or reduction in the loss of service availability to the minimum level achievable. And there's a minimized interruption to the business activities that allows the business to resume its services as soon as possible. Some of the potential consequences in the implementation of ITSCM are, first of all, a lack of resources, caused usually by a misunderstanding of the breadth of scope of what's required in order to restore the IT operations and the services to the business. There can be inaccurate estimates of the amount of damage that would be caused by any particular natural disaster or other disaster that might strike IT operations. The budget may be inadequate to provide the kind of infrastructure replacement necessary on the kind of a time frame necessary to bring the business services back into operation. There's a lack of commitment by management. ITSCM is probably one of the most neglected areas of the entire ITIL feature set or disciplines because it's the kind of thing that you may never need. And so it tends to have a relatively lower priority in terms of management's attention and commitment to it. And even with a commitment on the part of management, again, because it's something that's not immediately impacting the day-to-day operations, it may be subject to some delays in creating and implementing the plans in terms of promulgating them so that people have them in hand when necessary. Financial management for IT services is the fifth and final practice in the service delivery discipline as part of ITSM. Financial management for IT services addresses the customer's concerns about IT expenditures. Some of the key terms in this practice are accounting and budgeting, that is planning for and keeping track of expenditures, and charging, methods for recovering costs from customers. There are three major goals in this practice. First, the cost-effective management of IT resources to optimize service provision to customers, making the best use of our resources to give the best possible service to our customers. Second, to associate costs related to providing IT operations support to business services. And third, to provide support to the management decision-making process about making investments in the IT infrastructure. In terms of roles and responsibilities, different organizations approach having financial managers in two different ways. One is to have distinct IT-related financial managers whose responsibility is strictly IT accounts, and they're located in the IT operational area. The other approach is to have financial managers who handle a variety of responsibilities in the financial management department, some of whom are designated as IT financial managers, but instead of reporting to the IT director, may report to the financial management director. The key pieces for success of this integrated financial management responsibility is, first of all, the IT financial managers located in the financial management department must have process ownership. In other words, they must feel like they have dual allegiance, if you want to think of it that way, as being responsible not only to the financial manager but to the IT department. And they must have equal authority and be on equal terms with other financial managers, processes, financial managers who may be handling other departmental responsibilities other than IT. Financial management procedures include developing an investment strategy for maintaining the IT infrastructure and upgrading the quality of the infrastructure. Second, to prioritize the use of resources, since there's always more demand for resources than there are resources available. In other words, trying to get the biggest bang for the buck. Third, to support management decision-making regarding investments in IT infrastructure. And finally, to decrease the financial risk of capital investments in the IT environment. The action steps in financial management are budgeting, accounting, charging, and reporting. The budgeting action step involves the budgeting process, where we identify the key factors that are impeding the company's growth from an IT perspective and allocate resources in the coming year or multi-year cycle to alleviate those impedances. The budgeting methods include either incremental or zero-based budgeting. Incremental budgeting means starting with the existing budget, the existing expenditures for the prior year, and determining how much the line items need to be incremented. Zero-based budgeting forces us to go back to square one each year and justify each line item of expenditure in the budget for whatever department or operation we're considering. The accounting action step involves defining the cost elements that are recorded for each department or customer or product or service, depending on the focus of the accounting system. Defining the service elements, the services that are provided to the client, and then aligning the cost elements with the service elements so we see how much it costs to provide which services to the business. The third step is charging. Some organizations have a charging policy, and if they don't, they may at some point decide to choose an appropriate charging policy and communicate that information to both the IT operations and the business customers. The charging policy is where we will associate the costs of IT infrastructure with the individual business services that are provided to the customer. We will also specify which costs would be included in any proposed charging method. Then we would establish any pricing flexibility, such as the on-peak versus off-peak, as I discussed a little bit earlier. And then finally, to set the rates, for example, cost plus a certain amount to cover overhead, whatever the going rate is for the market, some negotiated rate with the customer, or a rate based on a targeted return on investment that the company has established for its investment in IT infrastructure. The action step is reporting, in which service level management gets information from financial management about how much was actually spent for specific IT services by customer, any variances between the estimated charges and the actual costs. So during the process of SLA negotiation, we can bring up this issue and either adjust the charges up or down if the customer is actually being charged for IT services based on the actual costs, and also resolve any disputes regarding charges, their causes, resolution, and so forth. This information, as I said, becomes part of the service level agreement review that's conducted on a regular basis. Since accounting information is generally collected on a monthly basis and can be aggregated by quarter, the quarterly SLA review is a typical time frame in which to review these financially related data points. Some of the benefits of financial management include accurately being able to calculate IT service costs, to fairly allocate IT service costs to internal and external customers, to justify charging methods if the organization chooses to charge customers back for IT services, help IT operate as a business unit by holding it financially accountable and allocating resources to it on an as-needed basis, to recover all costs so that all costs related to providing services to the business customers are identified, and in terms of budgetary and accounting processes, to recover all those costs. To review the charges periodically, as we talked about in the last slide, during the SLA review to determine whether the charges are appropriate or whether they're too low or too high, and to build a cost awareness with the customer. The customer from the business perspective may not be aware of the costs that are actually involved from the IT operational and infrastructure perspective in terms of being able to provide those services to them. Some of the potential consequences of attempting to implement financial management are recording and monitoring costs may be an unfamiliar activity for those involved in IT operations. It may be hard to find people who are familiar both with IT operations and financial management, and some of the process opportunities aren't well understood because this is one of the activities that's not done as frequently as some of the others. For example, opportunities not being well understood means that sometimes they're not taken sufficient advantage of, and understanding of the cost, for example, of providing IT infrastructure may not be as well implemented as it could be to fully recover the costs, as we talked about a few moments ago, related to the provision of operations and infrastructure to provide the kinds of services that the customer expects. In this chapter, we looked at the 5 practices that make up the service delivery discipline of ITIL: service level management, capacity management, availability management, IT service continuity management, and financial management for IT services. I discussed several aspects of each of these 5 service delivery practices, including their goals, roles and responsibilities, procedures and action steps, and the benefits and potential consequences of implementation.